Implementing hierarchical planning in LLM-based automation requires integrating various process and data modeling techniques. A coherent representation of an agentic AI system's operational space can be constructed by unifying familiar knowledge graph and low-code development concepts. This representation can include current and historical states, available functionality, objectives, and data. Events like user requests trigger system reactions that further propagate into real-time generated business logic, building adaptive workflows aimed at achieving user and system-defined objectives. Workflows can span across multiple goals and reasoning steps and describe the individual actions taken, as well as their respective results. Objective and goal-oriented approaches work well, as they provide an adequate framework for navigating practical user scenarios and can integrate with existing business process modeling concepts. Once a reasoning step has been completed, the system reevaluates the state of the knowledge graph and prepares for the next iteration of the process. Functionality is provided or can be generated dynamically based on the current goals and individual objectives, defined in the form of positive and negative outcomes. This can range from simple data search and communication features to domain-specific integrations and cross-system collaboration with other platforms. Automated workflows run until all deliverable-containing objectives have been completed, or can proceed indefinitely in cases where continued activity towards maintaining certain outcomes is required. To facilitate the reasoning and decision-making process, we define dynamic operational windows, containing encoded subsets of the functional knowledge graph that can be configured to fit into a given context size. Deciding how operational data is reduced and encoded, including the levels of abstraction appropriate for each reasoning step, is one of the main optimization problems of the system. A formal knowledge graph manipulation language provides a standardized interaction protocol between LLMs and the platform. We are currently running a benchmark to determine which open-source model is best at speaking a simple version of the language. Once we have a suitable base LLM, we'll release an initial test version of our assistant. The next step would be building an open-source library of user-assisted and purely synthetic workflows that can be used to train specialized planner models. Goal-oriented process simulations provide a great playing and self-improvement ground for machine learning, as many superhuman application-specific models have already demonstrated. We are excited to hear your thoughts and comments on the approach. Subscribe for regular progress updates and our latest GitHub releases.